Hello physical science students, and welcome to our video about electric current. We're going to look at electric current and what voltage difference is, what an electric circuit is, different kinds of batteries, what resistance is, Ohm's law, and AC/DC. So what is electric current? It is the flow of electric charge, the net movement of electric charges, you could think of it that way, in a particular single direction. It's measured in amperes, and we abbreviate that with a capital A. For historical reasons, we talk about the flow of electric charges in terms of what the electrons are doing. So what the negative charges are doing. That's how we think about the flow of electric charge. So in this current right here, the electrons are flowing in this direction. That's the direction of the movement of the electrons. The current is the opposite. The current flows in the opposite direction that the electrons are traveling. If there is no current, electrons will still be moving about, but there will be no net movement in a particular direction. They will just have some random movements, and we do not have a current that is flowing. In order to discuss current, we need to know what voltage difference is. And voltage difference is basically related to the force that causes the electric charges to flow. It's always measured in volts, and we abbreviate volts with a capital V. And if we think about sort of an analogy here, think about liquid, maybe say water. If water is in this container here, and there is equal pressure in both containers, and we have a way that the water can be transferred from one container to another. We have this little open valve. If these are at equal pressure, there will be no flow of water from one container to the other. But if we have these containers and we have different pressures, let's say there's this volume here and this volume here, and there's obviously different pressures, this water will flow from here to here when we open the valve. And you know that because you have probably played with things with water pressure, and you know that water would flow here. It's a similar way when we think about voltage difference. The difference in the voltage allows the current to flow. So if we think of it as high voltage over here and low voltage over here, we have the flow of charge from these electrons to here. That's the flow of the charge. The current is going to flow this direction because of our voltage difference. Sometimes voltage difference is referred to as electrical potential, so don't let that confuse you. Now that we know what voltage difference is and what current is, we can talk about an electric circuit. An electric circuit is a closed path through which electric current flows. So the electric current follows this path, and it's a closed path. Here in this example, we have the flow of electrons in this direction. Our current is operating in the opposite direction, in this direction. That's the direction the current is flowing. In the circuit, this battery, we call that the power supply, and it provides the voltage difference. And that's what keeps the electric charge flowing, and it keeps our current going. It's important to also note that if any one of these pieces is removed from the path, this actually is a switch. This switch, when it is closed, we have a closed circuit. We can break that closed circuit by removing any of these pieces. We could remove the wire or cut it. We could remove the bulb. We could remove the battery, and this would no longer be a closed path. And without a closed path, there will be no current. So we have some different sources for voltage difference. Here are a few of them. dry cell batteries, wet cell batteries, and electrical outlets. You are all very familiar with dry cell batteries because you use them all the time in different devices. And basically, the way this works is that when the two terminals, the two ends of the dry cell battery are connected in a circuit, a chemical reaction occurs inside of this battery. Electrons are transferred between some of the components in a chemical reaction, and as a result, the carbon rod becomes positive, forming the positive terminals. We also have electrons accumulating on the zinc here and making it the negative terminal. The voltage difference between them causes a current through a closed circuit. In the dry cell battery, the medium through which the electrons are exchanged is a paste right here, and that's what allows these chemical reactions to occur. In a wet cell battery, that medium is an actual liquid. We call that medium the electrolyte, and in the case of the wet cell battery that you're very familiar with, the lead acid battery, which is the one in your car, that electrolyte is the sulfuric acid, and that solution of sulfuric acid enables these reactions to take place inside this wet cell battery. Electrical outlets also provide a source of voltage difference. We've all used those. They usually, in the United States, give us 120 volts of voltage difference. There are some special outlets that can give 240 volts of voltage difference. And just to give you a rough idea, if we have a car battery that has 6 cells, each cell provides 2 volts, so these would typically give a voltage difference of about 12 volts. Dry cell batteries like this one are usually about 1.5 volts. You're also all familiar with a 9-volt battery, which is set up a little bit differently, but it's also a dry cell battery. Now let's talk about something called resistance in electric circuits. Resistance is just the tendency for a material to resist the flow of electrons. So an item or a device that would resist the flow of electrons would be a resistor. Those are created to actually cause resistance. Because of resistance, electrical energy is converted into other forms such as thermal energy. A resistor reduces current through all or part of a circuit, and in the process of reducing that current, it transforms some of that energy into thermal energy. That's why your cell phone sometimes gets warm. Why would we want to intentionally put resistors into a circuit? Well, the answer to that is that resistors help to protect really delicate electronic equipment. Sometimes if there is too much current that is being sent through a circuit, it can melt or break different components on that circuit. So resistors will reduce that current in the necessary areas so that it doesn't break. Resistance is always measured in ohms. That's how we say that word, ohms. It comes from this Greek letter, and it's written like this, ohms. And that brings us to the exciting Ohm's law, which relates current, voltage difference, and resistance in a circuit. Now that you know what all of these different components mean, we can put them into this lovely equation where we have current measured in amperes is equal to the voltage difference measured in volts divided by the resistance, which is measured in ohms. We can write it like this: current equals voltage divided by resistance. You can also rearrange the equation if it helps you to remember it differently. Voltage equals current times resistance, V equals IR. So let's put Ohm's law into practice and try this little example. The voltage difference in a graphing calculator is 6 volts, and the resistance is 1200 ohms. What is the current through the batteries of the graphing calculator? Let's write down Ohm's law. Current equals voltage, the voltage difference over the resistance. We know that we are being asked what is the current. So we want to find I. We don't know that. That will be our variable. We know that the voltage difference is 6 volts. We also know that the resistance is 1200 ohms. So this is pretty easy. When we plug that into our calculator, we get 0.005 amperes. Remember, we measure current in amperes. And last but not least, let's talk about AC/DC. It's more than just a rock band. The AC stands for alternating current, and the DC stands for direct current. What is that anyway? What does that mean? Alternating current means that the current is alternating. It's changing direction. And in the United States, the alternating current changes direction about 120 times per second. Many appliances use alternating current, like hair dryers and toasters. Direct current, on the other hand, never changes direction. It stays going, the current stays going in the same direction. Battery-powered devices use direct current, for example, flashlights. If you have ever used, and you all have because we have them in our room, devices like this, these are actually adapters that allow you to plug a battery-powered device into a wall socket. So these you can plug in to your wall socket with alternating current in it, and they will adapt that into a useful form so that you can use your direct current device. Things like portable music players, laptops, cell phones, those are use these AC/DC adapters. Quick review. Remember what electric current is, know what voltage difference is, and what resistance is. Know what we're talking about when we talk about an electric circuit. Different kinds of batteries and what they do for us, how they provide our voltage difference. Definitely know how to do calculations with Ohm's law, and you'll get some practice with problems on that. And what is AC/DC? Here are some advanced ideas. Research different type of batteries, make your own circuit, and answer some of these questions about an electric circuit. Could be fun and interesting. If you have other ideas for things to investigate or look into, please do those for advanced proficiency, and I look forward to seeing what you have to show me. See you in class.